sorry, or I didn't make it so you could see the top. So integer exponents, that's what these notes are. And then here is the table. You can go ahead and start filling in the table, or making the table. And then we're going to start here at 3 squared. So 3 squared. We know 3 squared means that it's multiplying times itself, so it'd be 3 times 3. Well, 3 times 3 is 9. 3 cubed. Well, 3 cubed means you're multiplying the number times itself 3 times. So it'd be 3 times 3 times 3. There are 3 3's multiplying. So 3 cubed is 3 times 3 times 3. 3 times 3 is 9, times 3 would be 27. Or, in your calculator, you can put 3, and then you can hit this caret and put the exponent of 3. So 3 to the third is 27. 3 to the fourth, 3 times 3 times 3 times 3. 3 to the fourth power is 81. Okay, 3 to the first power. 3 to the first power just means I have 1 3. So it would be 3. Okay, now, if you notice, each time it's multiplying by 3. So in this table, every time it's multiplied by 3 because there's an extra 3 multiplying. Now, I want to go up and do 3 to the 0. So this one is a little weird for some people. So if I put 3 to the 0 power, notice it gives me 1. If I put 500 to the 0 power, it gives me 1. Negative, oh, parentheses, negative 500 to the 0 power is 1. The reason why is if I put something like 4 times x to the 0, this, anything raised to the 0 power is 1, so it pretty much just cancels out, and you're left with just the 4 here. So anything raised to the 0 power is always 1, so it would actually be 4 times 1, which 4 times 1 is just 4. So really, the 3 to the 0 power is just, where did my pink pen go? Is just 1. But again, it follows this pattern of we start at 1, and then it'd be 1 times 3 gives you 3, 3 times 3 gives you 9, 9 times 3 gives you 27, 27 times 3 gives you 81. Okay, so again, if we want to follow this same pattern, and we want it needs to multiply by 3 each time, something times 3 gives you 1, or 3 raised to the negative 1 power is 0.33333. This is one of my favorite features on this calculator. It will take any decimal and change it to a fraction. So we did 3 to the negative first and gave us that decimal. Now hit math. And notice that first option says FRAC for fraction. So hit enter, and it says answer to fraction is, notice, 1/3. So this is 1/3. Then let's do 3 to the negative second power. 0.11111. We don't really know what that is as a fraction. So hit math again, and then enter, enter. So the answer to that one is 1/9. Well, let's see what 1/9 times 3 is. 1/3 times 3 is 1, times 3 is 3, times 3 is 9, times 3 is 27. So notice it continues that same pattern. 1/9 times 3 is 1/3. 1/3 times 3 is 1. 1 times 3 is 3. 3 times 3 is 9. So now let's look at this. Notice the pattern. So if I look at 3 to the negative first and 3 to the first, that's 1/3. That's 3. Look at 3 to the negative second. 3 squared, 3 to the negative second. 1/9 and 1. Do you notice a connection? Do you think we could find 3 to the negative third? It's going to be 1/27. 3 to the negative third. Oh, sorry. I got to go back down to the bottom. 3 to the negative third. Math, enter, is 1/27. So we have 1/3. This is actually, there's a rule to this. So if I have anything to the zero or to the negative power, so if I have 3 to the negative second, so it actually changes it to the denominator. So it'd be 1 over 3 squared, which is 1 over 27, or 1 over 9, sorry. 1 over 9. So this negative exponent moves the numbers to the denominator. So all of this information moves to the denominator, and it's no longer a negative exponent. So if we had 3 to the negative second, we could write it as 1 over 3 squared, which is 1/9. I'm going to go ahead and write 3 to the 0 cancels and equals 1. Okay, so let's do another one. So if we have 8 to the negative second, we're done with the table, so let's do another example. So you're going to put it over 1, and you're going to write it in the denominator. So I would put it as 8 squared. Well, you have to put this 1 as a placeholder. So remember, 1's a placeholder here, so 1 can be a placeholder here. Well, 8 squared, or 8 times 8, is 64. So it'd be 1/64th would be my answer. Okay, now let's do a variable, because sometimes that happens. If I have x to the negative fifth, put the placeholder. Anything divided by 1 is the same. So we're going to write it as this in the denominator, and it's no longer negative. So it would just be 1 over x to the fifth. So that would be our answer. Okay, what if I had 8 squared times x to the negative fifth? So 8 times x to the negative fifth. Well, this is the only part that has the negative exponent, so place it over 1. That's the only thing that moves to the bottom. So you would have 8 squared, and x to the negative fifth would move to the bottom. So 8 squared is 64. X to the fifth, you don't know what x is, so you can't multiply it out. So it's actually easier, in my opinion, when it's a variable and we're talking about exponents, just because you can't multiply it out, so you just leave it as x to the fifth. So we have 64 over x to the fifth. So those are integer exponents. Remember, integer is just numbers, so those are number exponents. And that's a few examples with variables as well.